The whole LLM hype cycle has definitely settled down.
Yeah, it feels like the real capital has finally moved on to hardware.
Exactly. We're not just generating text anymore, we're generating motion. We've moved from generative AI to, I guess, physical AI.
That's the term. It's officially the age of physical AI.
And today we're doing a deep dive into the physical AI horizon. It's this massive new industry report that details how AI finally got a working body.
Right.
We're going to look at the brain, this sort of new dual architecture, the hardware renaissance, and a pretty unsettling way these things are being trained in our own homes.
The whole mission here is to really get a handle on the shift, from robots as just programmed tools to actual embodied intelligence.
Okay, so let's jump in. First up is the cognitive engine. The report kicks right off with Nvidia's Project GR00T, and it looks like they basically solved that old latency problem.
They have, and it's because they totally changed the architecture. It fixes what they called the stuttering robot problem.
Where the bot has to stop and think before every single little move.
Exactly. They fixed it by mimicking how our brains work.
It sounds a lot like Daniel Kahneman's work, thinking fast and slow.
That is precisely what it is. You have a system 1, which is all reflex, fast, catching a cup before you even realize it's falling.
And a system 2 for the slow, logical stuff, like planning a path across a room.
Exactly. But the real unlock here isn't just the architecture.
It's the training ground.
Yeah.
The report really, really hammers this sim-to-real revolution.
Oh, it's critical. Absolutely critical. Because physical data is just so expensive and slow to get. You can't have a robot practice for 1,000,000 years in the real world.
So they compress time in a simulation. Yeah. They use these physics engines like Nvidia's Newton to run thousands of scenarios overnight.
Right. It completely solves the data scarcity problem. A robot can learn, say, 90% of a task inside the matrix before its code is ever uploaded to a physical body.
So it already understands physics when it wakes up.
It just has to calibrate to the real world.
Okay, so that's the brain. But a smart brain in a clumsy body is, well, it's useless.
Yeah.
It seems like we're finally past the whole crushing eggs phase of robotics.
We are. The big shift is in tactile sensing. You have things like XELA Robotics U-Skin, which allows for blind manipulation.
So it can reach into a bin and grab a bolt and know which way it's oriented just by feeling it.
Just by feeling it. It's mimicking our proprioception.
And they're safer to be around. I'm reading about 1X Technologies' Neo robot, and it uses compliant actuation.
Yeah, that's a huge deal. Instead of rigid hydraulics that could, break a bone.
Right.
Neo uses tendon drives. It's soft robotics. If you push its arm, it gives way, just like a human arm would.
You pair that with the move to solid-state batteries, like in the Xpeng Iron Bot.
Which won't catch fire.
And suddenly you have hardware that's actually safe for the living room, which is probably why industry is jumping on this. Figure O3 robots are already at BMW.
Hitting 99% accuracy in sheet metal loading, which is incredible.
Though it is worth pointing out that Tesla's Optimus is still fighting that classic production S-curve.
Oh, for sure. The demos look amazing, but scaling reliability is a whole different beast.
Right.
But while the industrial bots learn in the factory, the consumer bots are they're learning in a much more controversial way.
The teleoperation as a service model, this is the part that, I don't know, it feels a little strange to me.
It is strange. You buy a 1X Neo, you ask it to do a chore.
And often it's a remote human in a VR headset actually folding my laundry.
That is the model. The entire goal is to collect massive amounts of data to train the AI.
But you're inviting a stranger to inhabit a physical avatar inside your kitchen. That just feels like a massive privacy problem.
It's invasive. There's really no way around that. But from an engineering standpoint, it's the only way to capture the messy edge case data you need for real autonomy.
You can't simulate a toddler's messy room.
You can't simulate it perfectly, no.
Yeah.
If you want the robot to learn in the real world, it has to see the real world.
So we sacrifice our privacy today for the data flywheel of tomorrow.
That's the wager. And once that flywheel really starts to spin, we hit the final concept in the report, the physical AI cloud.
The hive mind.
The hive mind, yeah. If one robot in Tokyo figures out how to open a particularly tricky door handle, it uploads that solution.
And instantly, every robot in the global fleet downloads that skill.
Yes, physical skills that scale as fast as a software update.
A world where dexterity itself becomes an update. That is, wow. That is a wild future to consider. Thanks for taking this deep dive with us.